What's up, guys? It's Devin again, and here to help you with another free response. It's for calculus. This time it's number 2901, and it states, a storm washed away sand from a beach, causing the edge of the water to get closer to a nearby road. The rate at which this distance between the road and the edge of water was changing during the storm is modeled by a f of t. He noted in meters per hour. T is hours after the storm began. The edge of the water is 35 meters from the road when the storm began, and the storm lasted 5 hours. And the derivative of f of t is noted as f prime of t. So, let's start off with part A. Part A is, what is the distance between the road and the edge of the water at the end of the storm? This is simple. You just remember to take the integral of the rate and remember the initial condition, which is at t equals 0, f of t equals 35. In which case you'll get either of these answers, whether you round it or truncate it, it's fine, and you don't have to worry about units for this one. Part B. Using the correct units, you have to interpret the value of f prime of 4, which equals 1.007, in terms of the distance between the road and the edge of the water. So the easiest way to answer this is that after 4 hours of the storm, or from the beginning, the rate of change is 1.007 in meters per hour squared, because this is the acceleration of the rate. It's the rate of the rate, which is acceleration, so the bottom unit will always be squared. Now, on to part C. C. At what time during the 5 hours of the storm was the distance between the road and the edge of the water decreasing most rapidly? Justify your answer. The easiest way to figure this out is to do a table. The table will serve as your explanation and your justification, and all you have to do is pluck out the value that is the lowest, I believe. Yes. The most negative answer, which is at t equals, it's right there. This is the lowest. That is your answer right there. So you just circle this in your table, and indicate that that is the answer. That is the lowest time, and you should be okay. They won't take any points off now. On to part D. After the storm, a machine pumped sand back onto the beach, so the distance between the road and the edge of the water was growing at rate g of p, meters per day, where p is the number of days since the pumping began. And write an equation involving an integral expression whose solution would give the number of days that the sand must be pumped to restore the original distance between the road and the edge of the water. So, it's just you're reversing the taking the subtraction from the rate that you were given, and you get the rate of which to put the sand back on. This will keep everything back to normal. So it's just the negative integral equals this. But you don't know for sure that it'll take 5 days to do it, so you just put the top limit of the integral as x, and that is all you need to do. It's very simple, very easy. No need for any fretting. Calculus isn't that hard. You're good. Alright. Thank you for your time, and it's just been me trying to help you again. Thanks.